Okay, hello everyone. So this will be a second video that is on the same topic, which is topic this one. There's a arrow with but then if I'm not mistaken, it will be the same. It's actually still under topic 6, but we are looking at the second part of the topic, which is triangles and polygons. Okay, so there are just one part of this. I combine everything together. The second part will be mainly on the questions, on the exercises. Okay, so likewise we are going to just focus on all the theory and the questions that is coming with the handout. You will need to do it at your own pace. Okay, but we will need to come back to the class and then we will book on the discussion on the questions on marking whether your answers are correct or not. Okay, so first thing first, we'll be looking at triangles. Okay, there are different types of triangles that you will need to be able to see and also to look at what are the important terminologies. So some of the triangles that you will always see is equilateral triangle, isosceles triangle, right angle triangle, and these three. Okay, mainly these three: equilaterals, isosceles, and right angle triangle. Right. So here you can see, right, when we say an equilateral triangle means that three sides they all have the same length. So when a triangle have all the same length means that they also have the equal angles as well. So it's always fixed at 60 degrees only. Okay, for all three sides. So same length, same angle. This is what we call as equilateral triangle. Secondly, we have the isosceles triangle, which is only where the length of the two sides are the same. And then here we have the base, which is not the which is something that's different. The length will be different. So if we have two sides that are the same length and connect by one different length line, then this is known as isosceles triangle. So if you look at here, if you have two lines that are the same here, the base angle at the bottom will always be the same as well. Okay, so the base angles are also equals here. A scalene triangle is just basically where you have different lengths for all three sides and different angles for all three angles inside the triangle. Okay, then here we have an acute triangle. All right, means that all angles A, B, C, D, they are less than 90 degree. But even though they are less than 90 degree, they will add up to 180 degree. Always remember, a triangle always have a total of 180 degree for their full angles. Okay, and then right angle triangle over here is just like what we have learned last time. Right angle triangle means that inside a triangle there is one particular side that is perpendicular to one another. So you will usually see this square thing, which means that it's a right angle triangle. Okay, an obtuse angle triangle means that one of the length will be more than 90 degree, but also between 180 degree. Okay, so it will be something like a big one. So this particular angle is more than 90 degree, but it's between 180 degree as well. All right, so basically an obtuse angle inside a triangle. Okay, so these are the most of the types of triangle that you all will need to remember. Now looking at here, this is something that you might not see before. Okay, all right, it's a theory that is quite slightly new, I think, for some of you all. Okay, so here is angle properties in and out of the angle. All right, so look at this triangle, right? I have one triangle over here. Okay, ignore the line first. I will explain a few things first. So look at the first thing, the first property. Sum of all the interior angles add up to 180 degree. So let's say, for example, in this triangle, I have three angles only, right? So A, B, and C. So interior angles refers to A, B, C, right? So when they add up together, they can give me 180 degree. Okay, this is a simple principle to understand. Now, the second one comes to a point. Okay, so this is known as the exterior angle, X. Okay, and I can tell you that X, okay, X equals to angle A plus angle B. Okay, this is actually written here. Okay, this is actually written here. sorry, let's go to a simple one first. So we have an interior angle at C over here, and here is a straight line mark. So this one is known as the exterior angle. Can you see it's outside of the angle, right? So X here and C, when they add up together on the same straight line, they equals to 180 degree. Okay, so sum of the interior angle and the exterior angle at the same point. Can you see? I mentioned at the same point. This point. This is the same point. On a straight line adds up to 180 degree. Okay, 1 and 2 is still quite simple, but now it comes to this one. When an exterior angle will equals to angle A plus angle B. So what is angle and angle B? Angle A and angle B are interior angles that is not sharing a common point with the unknown exterior angle. So this is a bit different. Okay, wait, let me put in something for you. It's not sharing a common point. Okay, not sharing a common point. So angle A and angle B, I'm going to highlight them so that it's easy for you to see. Can you see angle A and angle B, we are adding them together, correct or not? So here I will have the sum of interior angles, the sum of two interior angles. Okay, then the sum of two interior angles that is not sharing a common point. Okay, not sharing a common point with the exterior angle. And here I mentioned is unknown, means that you are not so sure. So the exterior angle refers to the angle X over here. So if you look back at my diagram over here, angle X is the exterior angle over here, and A and B are over here. So what do you see? They are not sharing the point with the exterior angle. Okay, so means if you were to find an exterior angle over here, you can directly look at what is the opposite, okay, two interior angle and add them together. So when you add them together, you will automatically get your exterior angle over here. Okay, so this is slightly a bit different. Okay, a bit hard to grasp, but I actually do have a proof for you. Okay, so now look at angle X. Use the first and second rule to prove to you that this actually is valid for the third rule. Okay, so from the second rule, we know that angle C and angle X, when they add up together, they give me 180 degree, correct or not? So this means if I want to find out what is angle X, I need to use 180 degree minus the angle C. So this one, I'm still using rule number 2. Okay, can you see the 2 here means that I'm using rule number 2. All right, so this is the first thing. Second thing is angle A and angle B, when you add them together, okay, actually equals to 180 degree minus angle C. Okay, this one I'm using the sum of interior angles. So means that because initially the original equation should be angle A plus angle B plus angle C equals to 180 degree. Correct now? Now what I want to do is I'm going to put 180 degree. I'm going to pull the angle C to the other side, which is angle C over here, and only left with angle A plus angle B over here. So why do I want to do this? Because I want to show you that, do you realize that here on this second equation, 180 degree minus angle C also occur in the first equation over here, which is 180 degree minus angle C. So in this case, this means angle X equals to angle A plus B. Okay? Okay, so this is slightly difficult, but you just have to maybe rewind a bit and then listen through the recording again. Okay, but I will particularly look through this theory and concept again when we are coming back to our classes. Okay, so that's all for triangle. Now we'll be looking at particularly on all the different types of polygons. Okay, polygons means that you have more than 3 sides of a shape that has more than 3 sides. We have regular and irregular. So when we say it's a regular, means that all sides are the same. When we say it's irregular, means that all sides might not be the same. Okay, so let's look at some of the example. So a quadrilateral, you might see these words. When we tell you that you have a quadrilateral, means that you have uh, a shape that has four sides. So this means that rectangle, squares, kite, all these are known as quadrilateral. But why do they want to give them a quadrilateral name? It's because sometimes they cannot classify certain shapes into certain category. So they will only see the number of sides. So sometimes it can be trapezium bar, which you have heard before. But sometimes it's very irregular that we cannot really characterize them into any other shapes. So sometimes we will call them a quadrilateral because it has four sides. Okay, if you have four sides means that the sum of interior angles is always 360 degree. So interior angle means that any angle that is within the shape. So these, they add up to 360 degree. And one thing I always want you all to remember is that a quadrilateral is, no matter how, they are formed by two triangles. So if one triangle, the sum of interior angle is 180 degree, if you add two of them together, then now they are total of 360 degree. So like for example, square, trapezium, rhombus, and kite, they are all made out of two types, two triangle. Okay, they are made of two triangle and the sum of interior angle is 360 degree. Okay, so here we look at different types of quadrilateral. First one will be square. I think you have heard this before. They have four equal sides, four right angle angles which are equal also. Their diagonals are also equal of length and the diagonals bisect each other at 90 degrees Celsius. So the only thing that I want to always bring up to you, because it's something quite new, which is the diagonals. Okay, your diagonals for a square are always the same length, and when they bisect, they intersect each other, this one is automatically a 90 degree. So if it's 90 degree means here is also 90 degree, here is also 90 degree, here is also 90 degree. Okay, so this is for a square. Next will be rectangle. They have opposite sides length which are equal. So opposite ones are equal. They have four right angles just same as square. Diagonals are equal of length and they also bisect each other. But this is not 90 degree. Okay, this is not 90 degree. Parallelogram, opposite sides and angles are equal. So for example, here you have two parallel length over here. They are equal length and they are parallel. Then the angles also, opposite angles, they are the same. So A and B are the same. C and D, A and B are the same. Yes, correct. So A and B are the same, C and D are the same. All right, and then always remember on the interior angle, if you revise back the parallel angle, A plus C equals to 180 degrees. So the interior angles, they add up together, they are 180 degrees. Can you see the U shape over here? Okay, here also have a U shape over here. Okay. Okay, then here will be rhombus. It's very similar to parallelogram, but a lot of people will always forget because a lot of questions they only spam to test you on parallelogram instead of rhombus. But rhombus works this way. It's very similar to parallelogram as in because all four sides we can consider them as parallel to one another. Okay, the same as parallelogram, just that the only thing is different is they have four equal sides. So the moment you see if A all got parallel arrow, right, then you need to see whether is it equal side or not equal side. If all of them are equal side, then automatically they are rhombus. If they are not equal side, only the opposite one are equal side, then they are parallelogram. So you need to look at properly on the question and also the diagram, see how they annotate it properly. Okay, so these are some of the quadrilateral. Here we have another two more, which is trapezium and kite. Trapezium, you have a few different ones. Okay, trapezium, you have like that. This is a normal trapezium. This is an isosceles trapezium whereby your sides at the two sides are the same. So you have two angles on the top that are the equal. The two base angle here are also equal. So this is isosceles trapezium. And then for trapezium, it's also just simply something like that. This is a bit different, is it has a 90 degree over here. Okay, so they are not so much a characteristic for trapezium, but you just have to know that they are only have one pair of parallel sides. For example, this one, they are parallel. This one, they are parallel. This one, they are parallel. So they only have one pair of parallel sides. Okay, and also the same because they are quadrilateral, it's always 360 degrees, right? And then for kite here, so diagonals, they are not equal. Always remember, the only one that are not equal is kite, right? They are not equal. You can see a very long over here and very minor one over here. But they intersect each other at 90 degrees. That's why I put a square over here, right? And a pair of equal and opposite angle. So this one is here, they are equal. Here, they are not. Okay, this one is not equal, but this one, they are equal. Okay. Okay, so these are some of the quadrilaterals. Now we need to look at polygons. Okay, so this is slightly a bit more into calculation already, and you need to remember some of the formulas. Okay, here we have polygons, right? So there are formulas that you need to know. Because polygons can go up to more than 4 sides, 5, 6, 7, 8, 9, 10, 11, until 12, you might have heard before. So a very important concept that we always want to know that is, what is the sum of interior angle? So for quadrilateral, we have 360. For triangle, means 3 sides only, you have 180 degrees, right? So how do we usually find out what is the sum of interior angles within a regular polygon, which is through this formula. Always remember this formula. A sum of interior polygon is n minus 2 times 180 degrees Celsius. Not degree Celsius. Alright, so the n stands for the number of sides. Okay, the number of sides of that particular polygon. Right, so for example, if today you have four sides, which is a quadrilateral, then you put in 4. If today you have a 6 sides polygon, then you put in 6. Quite simple. Alright, first thing is sum of interior angle. Another thing is the sum of exterior angle. So the sum of exterior angles, always remember, no matter what kind of polygon you have, is always 360 degrees. No change. Okay, no change. Okay, now let me give you an example over here. Here we have a hexagon because they have 6 sides over here. Alright, so a regular hexagon, what is the sum of interior angle? So I'll use the formula. I'll put in 6 into n and minus 2. Then I'll multiply 180 degrees. So I will have 4 minus 4 times 180 degrees, and then I'll get 720 degrees. So then you ask that, then I know the sum, but how am I supposed to know what is the each of the angle? What will it be? It will be 720 degrees divided by 6. Then you can get that, oh, one angle is 120 degrees. So you need to be careful. The question usually will ask you, oh, what is the angle of one interior angle? Then you need to do 2 steps. You need to find out what's the sum first, then only find out what is the interior angle. Okay, so this is for interior angle. It's quite straightforward, but the only thing that comes into play is the exterior angle. Okay, the exterior angle over here, need to be careful is, how do I know that? How come exterior angle is all 360 degrees? See, this is what we call the exterior angle. Means if let's say I continue my line over here, and the angle that's up here, this is known as exterior angle. Same goes to this one. I continue my line all the way here. My exterior angle is the outside over here. This one also the same. I continue here. Then this is my exterior angle. Can you see the blue color one there here? And also the one that I circle. Okay. So then people ask that, how come this exterior angle, right, is 360? Quite simple. For this one, I can draw for you. So look at this one now. Now what I'm going to do is I'm going to take out all the exterior angle. Okay, now you can see the first one, the one that I circle in blue. I'm going to take this exterior angle out. Okay, so it will be something like that. Okay, then like this, and I draw one line. Okay, then now I'm going to take the next exterior angle, which is circled in red color, this one. Okay, it's actually like this. So here is, I put like that. Sorry. Okay, then I draw this one. Then I have this one. Okay. Then next, I will draw the green color one. I use the green color one. So green color one is like that. Alright, so I'll put in like that. Okay, and then this one, I will have a something like that. Okay, then I'll draw the yellow color one. Okay, the yellow color one is also the same. So it will start with this one, continue a horizontal one, and then a solid one. Here is, and then after that we have the normal one over here. So it's also the same, the dotted line, and then I draw up Here would be the exterior angle. Last one, okay, last one I have this one. Sorry, no, sorry, this one is supposed to be the other way because I'm following this line. Okay, this line is going this way lah. So I'm going to put my line here. Draw. Okay. And then the last one will be a black color one. So the black color one, you can see the direction. The direction is like this, facing this side. So actually here is the same. So I have a dotted line, and I have this one, and I have a solid line over here. So what do you realize? Can you tell? This is actually all the angles at a single point. So this means all the angles at a single point means they add up to 360 degree already. So all exterior can be put in together to make a full circle. So this is known as a 360 rotation. Okay, so all exterior angles, all exterior angles, they can be put in together and they make a circle. So in total they will become 360 degree. So you ask that, then if I know, what if the question asks me, I just want to know one exterior angle, what would be the angle? So it's quite simple. The formula would be 360 degree divided by n. So this is the formula. So n is the number of sides. So when you have 360 degree, you divide by the number of sides of the polygon, you'll be able to get what is the value of one particular exterior angle. Okay, and then one last formula I want you all to remember is, for each vertex of a polygon, exterior angle plus interior angle equals to 180 degree. So this is quite simple also. If you look at here, it's actually on a straight line. On a straight line. So you have two angles over here. One is the interior, one is the exterior. So they'll add up to 180 degree. Okay, so there are different types of names over here. You can look through from 3 sides to 10 sides over here. And I do have an example over here. Okay, this is supposed to be a pentagon. Let me write it down. Okay, so a pentagon is a 5 sides polygon. So let's say, for example, I'm taking this as an example, right? So a pentagon is made of 3 triangles over here. So you can see here, I can tell you, okay, made of 3 triangles. So here one is 180, one is 180, one is 180. So in total, if you times 3, you get 540 degree. But sometimes you don't know what is the number of triangles that they use to make up math. So then you don't do that. You just make use of the 5 minus n, 5 minus 2, 5 minus 2 multiply 180 degree, you will still get the same answer, sum of interior angle. So for any polygon, they are made up of n minus 2 number of triangles. That's why this is where the formula comes from, where n is the number of sides of the polygon. So this is just an example, okay, on how it actually works. Okay, so that's all for this one. You can try the questions over here. So I'll be also going through the questions over here for you to write down what are the things that I want you to jot down, right? So some of the annotations over here. So you just have to pause the video and then write down some of the annotations that I put in. Okay, so for this one I think is a different order, so I need to show you the one that needs to come here is this one. Okay, starting from here, look at the questions over here. Okay, these are example fund of x and y over here. So you have x, y, z over here, all the unknowns you're supposed to find. X, y, z, and also here we have x plus equals to 100. Okay, this one nothing to find, it's just finding all the unknowns, no annotations. Here is all no annotations. Okay, then you go back to 8.2 because I think it's the 8.2. Okay, here. Okay, then you only come back to polygons over here, which is rhombus. Here I mentioned already, tell you what is rhombus. It's just a slanted square. You can see they are slanted, right, and they are at the same length also. So find x, this is quite simple. So for this one, I want you to write down this one. Show that angle DAG equals to angle HAE. Okay, so there are no annotations, so all is quite straightforward. Find the unknowns. Okay, find the unknowns. Okay, this one you need to write down. Okay, find angle ABC and DCA. This is a regular pentagon, right? And then this one is a circle with a diameter in between. Okay, AD and AC are diameters. They want you to find BAD. Okay, down here, find the unknown X, Y, X. Okay, and then find X for the last one. This one, I want you to find X also. This one, I want you to find X, Y, and Z. Okay, so just pause it during when you are looking through the video and then copy down the annotations. Okay, so that's all for areas and polygons. Okay, look back at the theory one because these are very heavy theories. Okay, always revise back. That's why I choose this particular chapter to be recorded. Okay, so always refer back to to this recording if you need to revise on the theory. Right? So I will see you all during class and discuss these questions with you.